G'day everyone. Hope you're all having a good GCAP. Yeah? Yeah? I see thumbs up. It's good. Awesome. I'm excited to talk to you all. Just a little bit about myself. My name's Tim, funny enough. I've been in the gaming industry since around 2007. I've been worked in design, engineering, production, the last 10 years being at Wargaming Sydney as a quality engineer, with the last 2 years since October 2022 with Riot Games. So I'd also like to make this a little bit fun, so there might be some audience interaction later on. Are you up for it? Yeah. Well, I don't think it'll be that fun, but we'll see. All right, so let's get into it. So a while ago, I had a mountain of a task ahead of me. We were working on a new feature, and I had no idea how to test it. It was a new C# translation layer for a C# client to talk to our Python server. We had to propagate data between them, and it was kind of pretty complex. Luckily, we had a tool just for this occasion. So we created a copy, we analysed the feature, we planned it out, began executing, and boom, it's a fire. We hit a nasty bug with a specific combination of types. When we were incorrectly streaming them on the client, caused nasty crashes, and I would never have discovered it without this tool. I would have either missed it or found it too late. The nice thing about it was that actually, because of the tool, I had a path through the system. I had recorded it, I was able to retrace my steps and just test around the issue and find similar issues. And then it was at that point I kind of had like an aha moment. I realised I didn't need to worry about testing anymore. I had the perfect tool to get me out of pretty much any sticky situation that I had. So what are we going to talk about today? We're going to talk about an effective tool that will make your testing life easier, give you clarity over your testing process, and it's something that we use every day at Riot Sydney. We're going to talk about some of the problems we faced, which led to our solution. We're going to do a little bit of testing together ourselves in a walkthrough, a live demo. I'm scared about that. We're going to talk about why, when, and how you can use it, and some of the common pitfalls you might encounter. At the end of the talk, I'll also share the template with you. There'll be a blank version and one with examples and pre-filled, which you can take away with you. You'll also have my contact details, so you can get in contact with me anytime you want, and I'll help you use it. What am I getting out of this? Hope just the warm and fuzzy feelings of helping the game community, testing a little bit more effectively, and having a more engaging testing experience. I'd also selfishly want your feedback if you do use it. So why should you listen to me? Well, I don't think you should. Well, I'm not really here to sell you anything. I'm just here to show you something that made an impact on our testing, a big impact. But actually, don't listen to me. Listen to the developers who've been using it. So I had, before this talk, I had about 40 sent out a survey with about 40 developers respondents, people who used the template often, and asking them these few questions. So do you find the test template valuable? And 100% of those 40 respondents, 100% of those 40 respondents said yes. And do you feel that it helps prevent bugs? And again, 100% of the respondents said yes, which is great. Ask what do you like most about it. Here's just a few samples of their responses. There was actually quite a few responses. I had to cut this down. So it prompts good questions about risks and test strategy, which would otherwise be overlooked. It's a point of communication about implementation strategy. Gets me to consider areas to put preventative checks and areas to run tests. It's comprehensive but optional. You don't have to complete every part of it, but it's all there for you to check through and prompt you. Before I go on, I just want to have a quick word about what even is quality. Something that maybe not everybody's aware of, but I like Jerry Weinberg's definition, which is quality is value to some person who matters. So it kind of is to the point that quality is really subjective, and it's about a personal experience and personal interaction with software. I also like this diagram, which is if you're building the right thing, you're building it right, you're supporting it right, then eventually you're actually really doing quality. And my role as a quality engineer is really trying to bring those three circles together. So, we had a problem. We were all eager game testers, but most of us didn't really have a formal background in quality. The industry was kind of moving to agile with flatter management. We were embedded in teams. It gave us a lot of freedom to think and collaborate with our teams, but we were a little bit lost at sea. We didn't have like a formal quality craft experience, just what we'd learnt on the job. There are no real schools for quality engineering. You can't get a bachelor's degree in quality. There are certifications, but most are really superficial, like ISTQB. So we spent heaps of time learning together. We learned about things like context-based testing, rapid software testing, heuristics, critical thinking, modelling, the fact that quality does not equal testing, and test cases are also not necessarily testing. We genuinely just learnt the quality craft. At the end of it all, we thought we could give others a leg up. We knew there was a formula, and then we could bake it into our DNA. What we wanted to create was a tool for guiding both ourselves and people new to the craft to test holistically and effectively from the get-go. We need something that was powerful, something that was big picture focused, something that was collaborative, really easy to use, fit our workflow, was low tech, low cost, and also mentally stimulating. So our answer was actually a structured mind map. So we're not the first to use mind maps. We actually saw a great example of this at STPCon a long time ago. But I'm not ashamed to be standing on the shoulders of giants. But our first iteration was really huge and scary. It had everything in the kitchen sink. So what we did, we streamlined it, made it self-explanatory. We added missing analysis, some testing and reporting, some other things. So, what are we going to test today? Mario. Just as a refresher. I wish I'd put the sound in. So if you're not familiar, well, obviously, you should be. As a Mario player, I want to be able to jump so that I can feel a sense of challenge as I navigate past obstacles in the level. So, onto the walkthrough. So if you have questions throughout, feel free to call them out. I think this one might work, but what I'm going to do is I'm just going to write them down in the tool, and maybe if we have time, we'll circle back to it later. Cool. All right, let's dive in. Hopefully this works. Uh-oh. Shh, don't look at my passport. If I can type it in, that's great. All right, so this is MindMeister, but you could actually use pretty much any mind mapping tool as long as it's online and collaborative. Just kind of like MindMeister, just before I go on. So first thing that we do is we just clone this. So yeah, there's a few other ones like MindMap, Coggle, MindDomo, Xbind, a bunch of them. If you want like a specific export or something like that, just hit me up. I'll see if I can get it for you. Thankfully the internet is working today. Cool, right. So first thing I like to do is just go in here and name it. I usually name it after like the ticket title, whatever. And jump. Cool. And having a look here, you can actually see on the right, we have these different phases: pre-implementation, pre and mid-implementation, post-implementation, and the different sort of activities that you do in each of those. So we have analysis, with requirements, risk, software modeling, and Oracle. So we'll get more into it soon. Testing, reporting, and retro, and completion. Look. On the left, we have a legend. Basically, it tells you what each of these node colors should mean. And then also there's an information section in case you want to note down anything in particular. Cool. So let's move over to analysis and requirements. So this is one of the most important parts here, is because if you get the requirements wrong, then obviously you're not going to ship something that your users want or need. So it's important to spend the time here. So we have a couple of, we use interrogatives here to tease out some of these requirements. So let's have a look at, say, why. So why are we even doing this feature? Well, we're doing this to provide the player with an ability to help them to progress through the level. What is the end goal? To have a way for players to get through the world and on the way, retrieve power-up mushrooms from bricks, be the primary way to kill enemies, collect coins from bricks, or clear breakable bricks above them. So I've actually pre-filled this out, sorry, I should explain. You would actually go through and add this yourself as you were going. So what is the benefit to users or to us? Okay, well I think it's actually, so they have a more challenging and therefore engaging experience. Okay, so what are the requirements? So let's see. So what does this feature not even do? Okay. Well, it's not swimming or flying. Okay, better make sure of that. It doesn't allow players to jump in midair either. Okay, that might, maybe we'll add that later. What cases are excluded? Well, we're not going to worry about double or triple jumps right now. And what are you most worried about? I think this is one of the most fruitful questions. It's, so what I'm actually most worried about is the complexity of interactions between the player and the world, particularly with physics objects or the game level. And so how are we going to do it? Okay, so this is where we'd write down like actual technically how we might actually try and implement it. So when the user presses jump, the jump state is enabled, and a force impulse is applied to the bottom of the character. Mario will be pushed up into the air with gravity as a constant force being applied to bring him back down. On landing, the jump state should be disabled, and if you're in the air, directional input is ignored, and how much force that is applied need to be configurable for designers to experiment with. Okay, so who's going to use this? Well, actually, every player who plays our game. If it was a different feature, you might want to segment this out to different users or something like that. This is the point to do that. It will be impacted by this feature. Again, it's just every player who plays our game for this particular feature. And when is the feature in use? Well, when the player presses the jump button on the controller. Okay, that seems obvious, but wait a minute, which button? Actually, we hadn't thought about that. Maybe we should talk to the product manager. We'll add that as a follow-up thing. All right, what else is going on with the system, the user, or the team? Well, we actually have another team who is working on swimming right now, so maybe there's some interactions there we better think about. All right, we should check with the other team to understand when they expect to merge, so we can do some integration testing. All right, so that's the requirements phase. We've actually bumped into a couple of issues. For a feature that's not just a Mario, you might find that this is a bit more extensive, but this is a pretty simple thing. All right, let's look at risks. So the goal of this section really is to understand how risky this thing is, to understand how much time and effort we should spend on testing it. So also lit around this mind map, there is helpful text to tell you what it actually means. So for in this case, project factors, this is risks for things that are going on in the project among people, and they may lead to bugs. So in this case, we have a learning curve risk, because most of the team haven't worked on gameplay mechanics in the past. A lot of them were back-end engineers. We're just putting this team together. Okay, that's a problem. Maybe we should think about how we can mitigate that. Maybe we need some knowledge training or something like that. Poor control. Yeah, we're currently rebasing onto a new version of the engine, so maybe there's going to be some merge issues we should be concerned about. Rushed work. Yeah, we need to beat the swimming team. I don't have to do integration testing. They can do it. Bad tools. We're going to skip over fatigue and some other ones, but we don't have good testability at the moment, so maybe we should add some testability for this. And yeah, it's a completely new feature, so it hasn't been tested. There are more here. You can add mitigations for these right here as well. I'm not going to today just for brevity, but overall we sort of give it a risk rating. Today I'm going to give it a rating of 4 out of 5, which means it's pretty risky. We better spend some extra time testing this. We should also invest in testability, and maybe we should get some additional help. Maybe reach out to some other teams to get insight. So moving on to the next part in the analysis section, we have software modeling. This is where we actually try to understand what the feature actually is. There's a common mistake where people go into this phase thinking, oh, we need to add tests here. No, this is really just trying to understand what the system actually is. So there's various nodes here, but we'll have a look at function. So this feature does have calculations. We're actually calculating Mario's gravity versus velocity and that sort of stuff. There's an algorithm there. There's nothing really time related. We're not transforming anything, not changing data or anything like that. But we are sort of got a startup shutdown situation where we're entering and exiting the jump state. We also need to handle never leaving the jump state, so we need to add some error handling. We have some interactions here between Mario and enemies, coins, static rigid bodies, dynamic rigid bodies. And can anyone think of anything else to add here that Mario might be interacting with? Death? Yep, sure. Falling? Yeah, falling off the screen. Yeah, that's a good one, actually. I forgot about that.
Also jumping outside of the screen.
Jumping outside of the screen, yes.
Water.
Incorrect velocity, either coming towards you or away instead of just on the 2D plane.
So that would be like Z depth issues or something?
Yeah.
Yeah, okay. All right. Oh. We could go forever. So testability. So we're going to be adding a special jumping debug level for this as well, just so we can debug jumps. And we're going to add some debug commands as well. So really you can sort of see that we're trying to figure out what this new software is actually going to be. Having a look at the data, what data is it going to process or use? We've got some inputs to our system, our jump system. We've got the key press, which is an enum. We've got force impulse, which is float. We've got gravity, which is also float. Mario's velocity, though, is a double, so maybe we need to think about how that's going to work. I don't know. We do have some preset data because we need to have jump height configured in the debug menu. We also actually, you know what? We need to have some persistent data because we need to track jumps, how many jumps we have, because we're going to calculate that as part of your high score. So we need to track that too. There's some data sequences here, so the force impulse and then Mario's gravity over time. There's not really much cardinality with this data that we're processing, but some things with regards to big little data. So what's his minimum jump height? What's the maximum jump height? What should be the min-max impulse? And what should like Mario's velocity be? There's a bit of life cycle for this, so his velocity over time, and also just noise. So player jump commands could be kind of random. We won't go over all of them, but there's actually quite a few more. There's like what interfaces, what platforms should we support. Like for Nintendo Switch, maybe we need to think about having a help text for that. Also the button icon and localization to support the Nintendo TCR requirements or something like that. But also we depend on state machine library for the managing animations, and there's a physics library we need to use too. I'll just jump down to performance as well. So maybe we need to think about performance with this. So actually the maximum input delay should only be minimum 2 milliseconds. And our animations, we have a max size cap. It's 512 kilobytes for this. So we've kind of modeled the system. We understand a little bit about like what it actually is or what it needs to be. We're going to move on to oracles. Oracles is a bit of a weird abstract concept, but really what an oracle is it's just a mechanism for us to determine whether a test has passed or failed. So in this case, for Mario, my feelings oracle is I've played heaps of these games before. So I played Sonic, Donkey Kong, whatever game's right. Maybe we can use those as a reference to understand how Mario should be jumping a bit. Principles. So when you jump, usually it's up and then down, right? So gravity, that's a principle. People, well actually I know Luigi. He's pretty good friends with, he's known Mario for many years. So he knows how he jumps, so I should talk to him. And there's also things like user personas, like, all right, so Matt, we've defined a user persona as a casual gamer, and he wants a light experience that isn't too challenging. He wants to be able to feel as if he's competent, doesn't like confusing or hard to use game mechanics. And Kate, well, she's a power gamer. She likes to maximize return on investment, 100% complete the game, high scores, maximum points, all that stuff. Hates getting stuck or being slowed down. So maybe those user personas could help tell us whether something's a bug or not. And then we have mechanisms, which are references, which is probably what you're most used to. Things like game design documents, class diagrams, Wikipedia articles on gravity, that sort of stuff. So you can grab all this stuff together and you can reference this as you're testing to be like, how should I prove whether actually this is a bug or not? So that's kind of the analysis phase. Sort of expands out a fair bit. This happens pre-implementation. Sorry, I'll just move down. But now we get into sort of, it's a little bit more planning here as well, but this also incorporates the actual testing itself of the feature. So jumping to test techniques. These are a heuristic for creating tests. There are many interesting test techniques. This list includes 9. There's actually more, but we'll just start with these ones. All right, so this is where we actually think and design some tests. Cool, so function-wise, thinking about the things that we've done before, we're thinking about jump and some of the interactions that we already highlighted. So actually, we had coin, brick, enemy, other obstacles and level, moving obstacles, static obstacles, obstacles at different heights, but I'd totally forgotten about jumping into pits. Pits or off the screen. So we'll add those as well as things that we should probably test for. Domain testing. So this is about the data. So how do we test thinking about the data that we define in the software modeling? So taking a look here, we're going to test the value envelopes of Mario's jumps. So like the min, max height, max velocity, make sure we don't exceed that stuff. Claims testing, this is about testing things that you claim. So help text, tutorial text, that sort of stuff. We've got to make sure that that's accurate. Stress testing. Well, maybe we could do jumping around a lot, right? But I guess what other stress tests could we do? Can anyone think of any?
Button mashing.
Yeah, so that would be button mashing, yeah. So we're trying to stress out the system with like things that it shouldn't accept.
Not hitting the button at all.
So I'll add that to scenario testing, actually.
It's on screen.
Running, no jumping. Sorry?
Replicating animation, so it doesn't clear the animation after the jump.
Yeah, so trying to maximize the animations.
What if there were like 1,000,000 objects you jumped into?
Yeah. Trying to maximize. Sorry, what was the last one?
Animations, if it doesn't clear the
Yeah.
animation.
And what if there was millions of objects you were jumping into?
Yeah, 1,000,000 coins.
Millions of coins at once or something like that.
Maximize collisions.
Yeah. So you can sort of see how, like, I had thought of stuff, and I hadn't thought of any of this. How useful it is to get people to collaborate and start thinking about tests.
Think of the network areas.
For the network areas?
Actually, all the writing you just put.
Really? Oh, okay. Well, anyway. Oh my gosh. Okay, that's weird. All right, that I haven't seen that before. Okay, well, we'll continue. Flow. This is about trying various sequences in a row. So in this case, like, let's try a sequence of jumping from coin to brick to enemy to that sort of thing. But if you're thinking about other data sequences, there are different other flow states as well. Maybe we'll try some scenarios. So let's try running through the new levels that support jumping. Okay, let's try a simple scenario where we run, jump to pick up a coin, jump to break bricks, and then we maybe jump up to an enemy and stomp on the head. It's a basic scenario. And then running no jumpings, that's another good scenario. I hadn't thought of that. Why did it save that one? Anyway. All right. User testing. So how would a user test it? So let's try some user personas here. So let's try Matt as a casual gamer. All right, how would Matt play the game? Well, he'd probably go slow, maybe attempt to be non-confident, try playing that way. With Kate, well, let's speedrun it. Let's rush through the level, let's try and jump and play it really aggressively. Risk is kind of a tricky one, but it's kind of like trying to think of a risk that might happen. You have no idea how to actually replicate it or reproduce or make it actually happen, but it can be helpful. So maybe, how could we get into a state where we can't even jump anymore?
Give it to a QA test, a genius.
Yes, there you go. Or maybe we could get, how would we get stuck somewhere with jumping? Like,
Collisions.
I don't know, but we can do some testing to try and figure out how we can do that. So once we've done this, we've thought of some test ideas, now it's to actually come up with the actual test plan. So we like to slice this implementation or this feature up into slices. What's the minimum amount of time or minimal amount of functionality that we can begin testing on this feature? So the first thing, we're just going to slice A, just the core jumping. So you can just jump, that's it, right? Very basic, no animations, no anything like that. So we're going to add some automated checking for this. You might notice it's like test cases, but automated test cases. So we're going to add some unit tests. All right, let's add some unit tests for maybe the boundary values. We'll make sure that the algorithm's working. And then we're going to add an integration test to make sure that the state is triggered when button presses happen. And then maybe we'll add a system test for like maybe stress testing, lots of repeated jumps over and over and over again or something like that. Memory leak test, whatever. Each core jump interaction, maybe a simple scenario, something like that. And then we come to testing, and we've added some test charters here. So a test charter is kind of like an idea or an area that you sort of want to spend time doing some testing around. So we identified what the core interactions are. So I'm going to write a test charter here for core interactions. I'm going to try and time box that, because the thing about testing is you can literally test forever because you can't find every bug. So it's good to sort of limit yourself and have check-in points as you go during your testing. So we're going to test enemies, cool. Now, pretend that I'm actually doing the testing now. So we tested map 1 and 2. All right, we can kill a Goomba, that's fine. We went to a cliff area, killed some Coopers, all right, we jumped on a shell. Cool, all right, enemies seem to be working fine. All right, coins, we're going to test on map 3, collected 10 coins, first bricks, yeah, cool. Bricks, yeah, tested on map 4. Yeah, we broke the first section of bricks. We finished the level, breaking the bricks all the way along. And then we're going to try some other environmental stuff. So let's test the water. Booted up level 7, played past the first area. We entered the beach area. Uh-oh. We had like some slowdown and inconsistent jump heights when entering the water. We're unable to jump back out in certain sequences. So you know what I'm going to do? I'm going to add some more test charters because I'm concerned about this. I'm going to do some more exploration. So I'm going to add a test charter here for waterfalls, maybe some deep water areas, waist height areas. I'll time box those too. Cool, tested using log graphs, no problem. Tested deep water on maps 0 and 4, no problem. Tested weight height areas on these maps. Actually that was completely broken. And I think we should probably talk to the swimming feature team because I think they've probably done something here. And so on. You can sort of see how, just by glancing at it, you can now see how many bugs there is of this system that you encountered. You can come back here and actually change it and add detail and that sort of stuff. MindMeister is pretty good in that you can add like code blocks and all sorts of stuff. It's quite useful. Cool. Slice B, that's just going to be polish. For other more complicated or larger features, you might have many different implementation stages where you can actually start testing or do testing. That didn't save my change. Cool. That's all right. We can work offline. So automated checking. We're going to add some, for the polish stage, we're going to add some system level tests just to make sure that animations and stuff play. And for testing, we might add like sound interactions, animations, tutorials and help docs, and playing through all the new levels. And these is kind of generated from all the planning and ideation that we've done previously. Cool, so that's like the testing phase, and where we move on to post-implementation, which is like reporting in retro. So I like to have a test story, quality story, some sort of story to tell stakeholders about how the testing went, what the status of the product was, what you covered, how good the testing was, why the testing that you did was good enough. So I won't read all of this out, but basically what you want to talk about is what it is, what it does, how it works, how it doesn't work, how it might not work, in ways that matter to stakeholders. That's the status. How you tested, what you did, what you saw, how did you configure, operate, and observe the product? What have you covered with your testing? What haven't you covered, and why didn't you test that area? And then how good the testing was. This is actually one of the things that most often overlooked, but actually could make the biggest difference to how you test and your life as a tester, is why the testing is good enough. Was the testing good or not? Was it hard, slow, or weak? Were there any roadblocks, and how can the testing be better? To make sure to try to get that into your roadmap, to try and add testability or get better tooling. And then a good idea to have that actual discussion with the stakeholder, if you can. It's nice to have it here, but it's meaningless unless you actually talk to them. And then sprint review, there are other completion steps, so maybe you have sprint review or do something like that. You can include that here or not. Like, this is totally up to the team and how the team works or whatever. And of course, like DoD and whatnot. That's just there if you want them. Cool. So that is the walkthrough. Let me just jump back to the presentation. Yeah, worked. Cool. So this is all based off the heuristic test strategy model and the rapid testing framework and some other things, work done by some people called Kem Kaner, James Buck, and Michael Bolton. That's a whole nother presentation. If you're curious, I'll send you information about it. It's very good, very interesting, and great. But I guess who uses this? So everyone on the team can use it. It was initially just quality specialists, but when its value was seen, it's used by more people. Normally it's run through by the person who actually implements the feature, so often developers. And it can include and should probably include people from design, product, quality, and whatever subject matter expert you need in the room for that discussion. So quality activities are actually often blocked by quality specialists if they own all of the test planning, analysis, and all that stuff. And it's even worse if the quality specialist is sick, because then no code gets tested. But actually, it's not even the half of it, because it's all the code that gets committed that never gets seen to anyway. So with this sort of tool, you can be more of a guide to people who are implementing it. You can walk them through the process and they can start to take ownership of this themselves. And it becomes a much more parallelizable task. Much less code gets seen to, and yeah, just generally better software. The reason it takes about 1 hour to go through, it takes more initially, especially when you're explaining it or trying to work with the person to go through it. But it goes much faster as you learn what all those nodes are, like heaps faster, like cuts it down a lot. One common concern is it kind of takes a while to fill out, like an hour, I don't know. It feels expensive, but really it isn't, because the cost to benefit ratio is massive. So it's better to spend an hour here and catch a bug here, because you can just fix it in requirements or just a quick code change. But if that bug goes live or something like that, that could be eight hours to multiple days trying to fix that bug. So when can you use it? You can actually use it for any new feature. It's a little bit size dependent. You probably wouldn't use it for something super micro small, or maybe super low risk. You can use it at the epic level as well if you want. You can even use it when you're first testing a product. You can actually even use it for release testing itself. What it can't do though is it really can't think for you. So you can't switch off. You still really need to think critically about the software under test. You need to put in effort. And you need to be looking at like the project environment and have a good understanding about what's going on around you. And you just generally can't get complacent. What it also can't do is it can't do like a long-term sort of test strategy or how you really want to work in general. Like that's kind of more best workshopped with the team. There are other tools for things like that, like risk storming, which if you want to, that's a whole nother talk as well. But if you want, you can reach out to me about that too. Also can't solve quality mindset problems. If the team doesn't care, this template will not fix it. But what it will do is, as a quality specialist or someone testing the product, it's going to give you a super awesome foundation of credibility and evidence that you'll have a well-written test artifact that documents your logical, consistent, and effective testing. And there's a clear link between action and outcome. And it becomes a lot easier to convince people that, hey, this is why we need to do testing, because look at all these things I found. It's very clear. So then we were sort of unsure what to do to deliver quality. There was like lots of questions. But now, very confident. When it's time to test, create a mind map. There's no more uncertainty. The process is very clear. You can get a great result. Then before, we didn't really have a detailed record of why and how we were doing testing. It was only reporting the outcomes, like test cases passed or bugs reported, that sort of thing. Now we have a good database of test artifacts, which documents our actual test planning, execution, the results of those sessions. I guess where we'd like to take it would be maybe integration with Jira would be nice. Maybe streamline it more with, make it, but without losing any fidelity. Add more mechanisms for self-coaching, like links to workshops or whatever, I don't know. And maybe like a dashboard or something, cool. So if you're keen, I would love for you to try it 3 times. Just 3 features. If you're not satisfied after those, your money back. Actually, no. Then send me an email about it, and because I'm eager to know why. So I really hope that you give it a try. There's the QR codes for the blank one and the example one. And I guess, are there any questions?
How would you go, or could you use this in regards to testing things that are slightly more nuanced, or not nuanced, that's the wrong word, that aren't more aesthetic?
Like a charisma-based thing?
Yeah, like you want the music to make the player feel a certain way.
That would come down to user testing, I guess.
Yeah.
Be like, I want to have, like, you could add that as a user persona, like people who care about this stuff. That's actually also in the heuristic test strategy model, is a charisma thing, which is, it's not in this mind map, unfortunately, but maybe I'll add it. James?
So, whereabouts do you identify in all those sort of steps things that need more routine sort of regression testing? So this sort of seems like it's associated with a specific ticket. So longer term, what would you extract out of that?
For regression testing, or things that need longer term testing?
Yeah, so like those water interactions seem like they were more fragile. Whereabouts do you sort of identify that, or that's more ad hoc?
So you'd probably go back, like this should be like a living document while you're doing development. You'd probably go back and add it to this section here, and then you could be like, oh yeah, we added it. I'm going to add an emoji. Well, I can't add a very good emoji here, but say that one. Okay, it's not saving because of the network error. But yeah, you add an emoji, you say, I've done that task now, and you'd be revisiting this. You would add it to this section here.
Okay, so you revisit each of these different sort of ones every time you do sort of more overall testing.
So say you found the bug with water.
Yep.
You'd be like, all right, we need to add some sort of automated check or some sort of long-term check, and then you would mark it off to say that you've actually done that. You've actually added it to the automation framework, or you've actually added it to like a test case software, right? It's kind of like a task tracking tool as well. Any other questions?
Can you repeat the question?
Yes, sorry.
I was going to ask, do you still use this mind map system when you take into account outside testing, like general play testers and features that they might request or changes?
For like change requests or new features?
Yeah, so like, let's say you got somebody from outside the workforce coming in and play testing and stuff. So they haven't been integrated with your mind map systems or when requesting features. So would you like tag along with them and create something like this?
I haven't done that. We'd probably just figure out what they need. Oh, sorry, the question was, would you involve end users in this for when they had like feature requests for when they're testing the product? I haven't used it like that. Usually I would get that feedback from them and put it in Jira, and then we'd have a task that we'd take for that sprint, and then we'd use the mind map across it. Yes?
Have you ever used this tool for testing narrative-based things in the game? So, like pathways through the game, where they have to take certain actions and you don't know where to end up.
I haven't, but that would probably come under the sequence testing. So you'd be thinking about where did I put it? Scenario or sequences. Sequences is up here. Well, that's data sequences, but you know, flow. There's a few points where it might make you think, okay, I need to think about what the flow is here, and you'd mark it down there. Yes.
Hey, something I never quite understood, including when doing these on your team.
Oh, thanks, Bilal. Cheers.
What exactly is the point of the software modeling section?
What is the point of the software modeling question?
The section.
So that section is to break down the software, to understand what the software even does. So if I didn't know, if I hadn't actually thought about what data we would have here, I wouldn't know that we should be testing like Mario's jump height or his velocity, that sort of stuff, without having done this step. So it's really about teasing out details or information. So I could be like, all right, maybe I need to do some sort of testing to make sure that his velocity is like the right accuracy, because it is a double, as compared to the inputs which were floats, right?
Okay.
This section was actually the thing that allowed me to catch that C# de-streaming error, because I was thinking about the data types. Yes?
Sorry, this is really obvious. Is it so? Would the QA person fill out all of this, or is it assumed that like a production person would fill out the top and then the developers fill out the middle, or is it?
You can do it all yourself as a quality specialist, but I would definitely recommend involving the people that have the answers in that meeting, because it makes it a lot simpler.
So you'd all maybe be on a call,
Yep.
filling out your own section,
Yep.
and would you then go over the whole thing together?
You can do that, yep.
Okay.
Yeah. That is actually quite effective. You can even do it asynchronously. So you could have like a legend. You could define your own legend. It's all customizable, right? You could have a legend. You could have a purple note is something that someone needs to get back to. You can add people. You can be like, you can do things asynchronously if you need to.
So I feel like.
Sorry. Sorry.
Comment on that more than a question. So for example, we have a small team, I actually work with a lot now, so we're going to probably use this at some point. So we have kickoff meetings for new features, and that's where I see this fitting into our development
Yes.
cycle, because that's where we're sitting down with engineers, with design, with QA, and
Yes.
discussing all of these requirements.
Yes.
And I can see this being a useful tool, not just for like that QA person, how am I testing this, but the team, how are we implementing this for internal environments. It's really cool, and I like it, and I'm going to use it.
Right, awesome. Yeah, well, it's about like having a. Sorry, I can't repeat all that, but that's awesome. It's about if you look at the thing about the circle back before, it was about building the right thing, building it right, and supporting it right. It takes everybody from different disciplines to make that happen. But again, it's just about the quality specialist role and bringing that all together, which is literally bringing people together to talk about it, to think about the problems that might actually happen, so we can fix them. Yeah. Sorry, there was another question. Any other questions? Yep.
I guess I was just wondering how granular you get with this, because it sort of seems infinitely granular if you want to.
Yeah, it could be. So that's where you. So how granular do you get with this? Is the question. So this is where this risk rating comes into effect. So you could be like, actually, this is super risky. Like we would go through all the risk factors. We're like, this is actually really dangerous or risky, or because some of these questions here, like in operations, is like, is this a popular feature? It's like, yeah, it's pretty popular. We should spend a bit of time testing this, right? Because everybody jumps all the time. So if this breaks, like that's our core game gone. So we're going to spend a lot of time testing this, right? So how you will think about how much time that would make sense for your particular product and your risk appetite, or not appetite, but your risk level.
Yeah, thanks for the talk. I have a question about the unit testing section on this. What's your opinion of using Cucumber or BDD in comparison to, explicitly stating the when, whys, and specifying all the unit testing? Because I saw that you might have to like physically or manually tick it like red, green on this document, whereas like in an automated like testing with Cucumber, you could have all the documentation as well as unit tests and have it automated. Are there any advantages that this proves over something like that?
Well, this would be in tandem with BDD maybe. So it might be like, okay, I need to write a BDD test for this scenario, and then you go off and do the scenario and do the given when thens and all that sort of stuff in your feature file separately. So this is really just about sparking ideas about what task you might need to do. Yeah.
That risk rating number that you had, is that auto-assigned, or do you assign that yourself? And then is there a way to show what it's out of? Because like 4 out of 5 is obviously high, but 4 out of 100 is nothing.
It has it here. Give the software a rating from 1 to 5. Sorry, yeah, where 5 being the riskiest. How can we mitigate the risks that we've identified? You could do whatever scale you want. So the nice thing about this is you can change it.
But it's not automatically generated.
No. It's you need to talk about it. Yeah, it's a bit. Any other questions? I thought I did. Oh. The question was, could you have any different scale? Or what is the scale here?
What I hear.
Yep.
So just to be clear, at the end when you're going over, okay, we tested, map 1 and 2, hitting the enemies and stuff.
Mm-hmm.
When you do more tests, do you still add that to this document and say like, hey, we tested that again and it's still working? Or do you just update whenever it changes status?
Yeah, so I'd probably come, I personally, and other people might do it slightly different, I would come back and actually update this node to be like a green tick. Or I think I used to keep the bug emoji and I would change it to a different color. But other people work slightly differently. You can have your own legend, your own system of tracking things. But yeah, definitely you would come back and say, this is done, this is fixed. In fact, you can make this being complete and filled out and signed off and all that jazz as part of your DoD. Cool. Any other questions? Yep, sorry. Yep.
Excuse me. My question is around, this is extremely detailed. Are there variants that are less detailed, so it could take 10 to 20 minutes to fill out? And then also, how would you go about integrating this into Jira?
So you could just link, well, to repeat the question is, this is very detailed, how could you make a version that's just 15 to 20 minutes? And the other question was, how would you integrate this to Jira? So number 2, I have no idea. That's one of the things I'd like to do. I think you can just link to it in the ticket to start with, just add it as a link. It's a good start for each feature. But for the first question, you can make this as big or as small as you want. And as I said, once you get familiar with it, this seems very daunting, but I would get through this in about 20 minutes.
Just to add something on linking it to Jira, one thing we used to do, which I don't remember, is have a task list, and Jira can automatically add the task list, and then you have a tick box to fill in this.
Yes. So it's part of the DoD.
You can't mark the ticket as done until you tick that, which requires you to do this. So, thanks.
You probably also use the risk rating as a priority as well.
Yep. Yep. So you could get to the risk rating section. You could do the first part, get to the risk rating, and be like, "This is a 1. I'm not going to do the rest."
What format would you like your feedback in?
What format would I like my feedback in? I don't know. Poetry, please. Yeah. Haiku. Thank you. Yeah. Thank you. I think we're close to time. Are we? Maybe got one more question. Yep.
Still trying to figure out how to phrase this question. Do you perhaps have any cautionary tales that you perhaps have when you're first implementing this that you would share as forewarning to others who might be still learning on the job themselves and going, hey, if you're doing this, don't do X, Y, Z or avoid X, Y.
Yeah. So I think cautionary tale is making sure that people are actually taking the time to think. Sometimes people will just skim through it and they won't add enough detail, or they won't think about some of the modelling hard enough, because for some of that you've got to sit there for a few seconds and be like, yeah. But some people will just look at it and be like, yeah, that doesn't apply, that doesn't apply, that doesn't apply. So just making sure people are slowing down and considering things as they go. And we're at time. Sorry. Thanks everyone.